Hello, this is Daniel Fritz of Daniel Fritz Mathematics. And here we're going to be talking about differentials and the calculus sequence where we're going to learn how to calculate increments. So let's look at some notes here on the board, what I have written here. For y is equal to f of x, some function, delta x is the change of x here, where x of 2 minus x of 1 is a representation of that. So that if we solve for x of 2, we get that x of 2 is equal to x of 1 plus delta x. And delta y is equal to y of 2 minus y of 1, which actually here is like the function that we will have, f of x of 2 minus f of x of 1. Here we have the function, some function with the value included. So this is sort of like the piece of the rate of change. And we talk about the rate of change a lot with dealing with this type of problem. F of x of 1 plus delta x minus f of x of 1. Let's go over here for a second. Zoom in on here. This is the difference quotient. And the difference quotient, which is f of x of 1 plus f of x plus h minus f of x. Again, look at this top here, right? F of x plus h minus f of x divided by h when the limit of h approaches 0. Sort of, this is kind of similar to the top piece here, almost, right? Similar, very similar. So this is the difference quotient for finding the derivative, and you'll find this thing called the instantaneous rate of change. Now, when you have just this representation here, f of x plus h minus f of x divided by h, that's considered the rate of change. The rate of change. So delta y will represent the change in y corresponding to the change of delta x in x. And delta x can be either positive or negative. So showing this is applied to the graph. We have x of 1, and then we have some output of f of x of 1. That's a point. Then we go to f of x of 2, and we have some value output of f of x of 2. So we draw the line through the curve here, and this is represented by y is equal to f of x. So we see the change of y over the change in x. So delta y is equal to f of x of 2 minus f of x of 1. And that also can represent what? F of x of 1 plus delta x minus f of x of 1. Right? And then here, f of x, you have just x of 1 plus delta x. So here, this is how the graph would actually look. And let's look at a problem. Now, given this function, y is equal to f of x is equal to x squared divided by 2, we want to find what? Delta x. We want to find delta y. We also want to find delta y over delta x. So look at this. For x of 1 is equal to 1, and for x of 2 equal to 2, let's calculate this though. So delta x is equal to x of 2 minus x of 1. We see that. And so what we have here, look up here again, x of 2 is going to be what? 2. X of 1 is going to equal to what? 1. So 2 minus 1 is equal to 1. So delta x is going to equal to what? 1. Let's look at this. Delta y. We want to calculate delta y. Now, look what I've represented here. Where we have f of x of 2 minus f of x of 1. This is understood to be the function, this function here, x squared divided by 2. Minus, again, x squared divided by 2, but we're going to use the values of x of 2 and x of 1 substituted for x. So we're going to take this here, we're going to take x of 2, and we're going to put this right here, and substitute it in here in this part of the problem. And then we're going to take f of x of 1, which is 1, and substitute it in that part of the problem. And here's its representation here, as you can see. 2 squared divided by 2 minus 1 squared divided by 2. If I said that right. 2 squared divided by 2 minus 1 squared divided by 2 is going to give you 4 over 2. 4 divided by 2 minus 1 divided by 2, which is 1/2, is going to equal to 3/2. So guess what delta y equals to? Delta y equals to 3/2. So let's calculate delta y over delta x. Delta y over delta x, showing this representation of f of x of 2 minus f of x of 1, right? And so here we see that what? That same function, we're going to plug those values in, 2 and 1, and this is what we get right here. So now we have what? We have x of 2 minus x of 1. This is going to equal to 2 minus 1, so 3/2 divided by 1 is going to also give you a rate of change of delta y over delta x. So delta y over delta x is the rate of change. So this represents the rate of change, right? So 3/2 is the rate of change. So this is the great thing about mathematics, the algebra and the calculus sequence, because slope can also represent the rate of change, because slope represents the steepness of the line. But in calculus, we also calculate the slope of the tangent line, which in this case, we're not showing any, we're not having a tangent line per se, but we're actually talking about increments, and we're also calculating what is represented to be the rate of change. So let's look at another problem real quick. So for f of x of 1 plus delta x minus f of x of 1 divided by delta x, here we got x of 1 is equal to 1, and delta x is equal to what? 2. So we're going to plug these values in where they belong. So 1 plus 2, f of 1 plus 2 minus f of 1 divided by 2, which is give you f of 3 minus f of 1 divided by 2. We're going to take that same function, f of x is equal to x squared divided by 2. And what we'll do is we're going to calculate its rate of change here, where we have 3 squared divided by 2 minus 1 squared divided by 2. So 9 over 2 minus 1/2 divided by 2 will get you 4 over 2, and that's going to equal to 2. Any questions? Always get in touch with me and we'll do future videos on the subject matter. And for now, this concludes this video on increments.